All right, second lesson in trigonometry, the 6 basic trigonometric functions. The 6 basic trigonometric functions are the sine, the cosine, the tangent, the cotangent, the secant, and the cosecant. Now, when we are actually writing these in the context of our trigonometry, they're abbreviated sine theta or sine x. Again, the variable doesn't matter, it's a dummy variable. Sine x, sine theta, sine beta, cosine theta, tangent theta, cotangent theta, secant theta, cosecant theta. Okay? These, sine and cosine, are the fundamental functions. All of the other functions are defined in terms of one or both of these. Tangent theta is sine theta over cosine theta. Cotangent theta, which is the reciprocal of tangent, is of course cosine theta over sine theta. Secant theta is 1 over cosine theta. Cosecant theta is 1 over sine theta. Okay. So, those are the 6 basic trigonometric functions. Let's take a look at them in the context of the unit circle. Okay? So if we draw our unit circle, and again, the equation x squared plus y squared equals 1. Center at the origin, radius 1. I should probably get something to help me draw good circles. All right. We'll make it the unit circle momentarily, but right now I just want you to understand that on any circle, you could find the trigonometric functions. All right? First of all, you know that trigonometry comes from triangle. Trigonometry, 3-angle measure. Okay? And you have studied trigonometry, no doubt, with respect to triangles. Well, even in the unit circle, or in any circle, we can create our triangles by just dropping an altitude to the x-axis, or bringing one up if the angle were down here in the 3rd or 4th quadrant. And of course, if the radius is r, and every point on the unit circle being x, y, on any circle, sorry about that, any point on the circle being x, y, the point where the terminal ray meets the circle x, y, well, this height is y. The sine of theta, you know to be opposite over hypotenuse in a right triangle. Well, here it would be y over r. And this is x. And you know that the cosine is adjacent over hypotenuse. Well, here it would be x over r. Well, now, if we use the unit circle, the unit circle whose radius is 1, this xy is actually cosine theta, sine theta. Because again, the sine would be y over 1, just y. Cosine x over 1, just x. And so, sine theta being y, cosine theta being x, in the unit circle, tangent theta, sine over cosine, y over x. Opposite over adjacent. Cotangent, cosine over sine, x over y. Adjacent over opposite, etc. Okay? So the unit circle can make these things really easy to do. Now, all that matters, and this is a hard concept to grasp for a lot of people, but all that matters in determining the values of the trigonometric functions for any angle is where you end up on the unit circle. All right? If you go around this circle 4 times and come back to this same place, the sine and the cosine and all the trigonometric function values are still the same as if you had just started there and gone right to here. Or if you even went backwards. So for example, here's pi over 2, which we've seen already. If you went around the circle once and came back to here and it was now 5 pi over 2, the sine and the cosine are still the same. All that matters is where you are on the unit circle. It doesn't matter how you got there. So, if that's the point, the x and y are still the same, the sine and the cosine are still the same, and again, all of the others are still the same. Y over x, x over y. Secant is 1 over cosine, cosine is x, secant 1 over x. Cosecant 1 over sine, the sine is y, 1 over y. All right. If you know the point that you're at on the unit circle, then you know all your trig function values. Now, what that means for us is that we can for any angle that is a multiple of our standard angles. Now, what am I talking about with standard angles? There are certain angles that are considered to be standard angles. They are used as reference angles for other angles. And I'm going to draw this table. I'm going to write up this table. And this is something that every student who has to study trigonometry should know. And I'm going to write the standard angles here. And this is in radians: 0, pi over 6, pi over 4, pi over 3, pi over 2. Okay? The sine of 0 is 0, the cosine of 0 is 1. And if you doubt these, consider this. Again, here is 0. The cosine is the x coordinate. Well, this is at the point 1, 0, because our radius is 1. Cosine is 1. The sine is the y coordinate. The y coordinate here is clearly 0. Right? At pi over 6, as we move up, and think about this too. You can relate the unit circle to the graph of the sine function. You know the sine of 0 is 0. As you move toward pi over 2, where you know the sine is 1, you start to move up. You start to move up. Y is increasing. At pi over 6, the sine is 1/2. The cosine is the square root of 3 over 2. So at pi over 6, you would be at the point. Square root of 3 over 2, 1/2. At pi over 4, both the sine and the cosine are the square root of 2 over 2. And again, you're still moving up. At pi over 3, now the numbers for pi over 6 are reversed. At pi over 3, the sine is the square root of 3 over 2. The cosine is 1/2. And then finally, at pi over 2, you reach the point where these numbers are reversed. The sine is 1 and the cosine is 0, because clearly you are at the point 0, 1 here. And so you've gotten to here. As you move to pi, you go back to where your sine is 0. Remember, this is the graph of y equals the sine of x. And then as you move to 3 pi over 2, you go to the point where the sine is -1. And then as you come back to 2 pi, the sine returns to 0. And then you go around the circle again, and then you start all over again here, which is again why we say the period is 2 pi. One time around the circle, we go through all of our positive y values, all of our negative y values, and then we start over again. The amplitude is 1. Why? Because the sine could never be greater than 1. You'd have to be outside the circle to have a y-coordinate greater than 1, or less than negative 1. So, the domain of the sine function and the cosine function, all real numbers, the range, negative 1 to 1. These standard angles, all right, know their value. Because if you know these values, obviously from what we said before, where tangent, cotangent, secant, and cosecant are all defined in terms of sine and cosine, if you know the sine and the cosine, you know all the other trig function values, or you can figure them out very quickly. And here's the really neat thing. If you know those, again, you know the values for any multiple of those in any quadrant. All right? If I'm over here at 5 pi over 6, the sine is going to be the same as the sine of pi over 6. The cosine will have the same absolute value, but over here, remember, the cosine is the x-coordinate, it will be negative. If you go over here to 7 pi over 6, both sine and cosine will be negative. Even if you had some angle, suppose I wanted to know the tangent of 47 pi over 3. Okay, first of all, I make sure that's reduced. You know, that isn't really something to any of this. 47 pi over 3. All I need to know is, I need to know what quadrant am I in. Well, 47 pi over 3. One time around the circle is 6 pi over 3. Right? Then you get 12 pi over 3, 18, 24, 30, 36, 42. 47 pi over 3 would land you in the fourth quadrant. It's a multiple of pi over 3. Cosine is positive, sine is negative. So the cosine of 47 pi over 3 is 1/2. The sine of pi over 3 is negative the square root of 3 over 2, because in the fourth quadrant we have a negative. Okay? So know these, be able to figure out what quadrant you're in, and you'll be able to figure out trig function values for a whole bunch of different angles. And that's it.